All right, let's learn something today, guys. Let's try something new. Straight out of All right. Let's determine the functions given the values and find out our... so now we aren't doing our explicit formulas and stuff, right? We're going to be doing f of x almost every time, okay? Now, that being said, if you use a recursive formula or explicit formula, it's the same formula, so we're okay. So let's do this. We haven't done phi, right? Okay. What's my formula always look like? It's going to be f of x equals a times b to the x, right? Can I find an a pretty quick on this? Do I have an initial value? My initial value is when x is 0, right? So right away I know a is 3. Oh, buddy, this isn't bad. We can do it. I like to put the b in parentheses. Now all I have to do is, how do I get from 3 to... Ooh, how do I get to 3 from 3 to 6? Yeah. Did that work? What's 6 times 2 equals 12? So what's my rate? What's my b? Maybe I should start with this in this class. Start with this section. All right. So now, is this a growth or a decay? Why is it a growth? Yeah, my base is bigger than 1. My rate is 2. So it's going to get bigger. Let's go. All right, let's do B, rapid fire style, but not really. What's my initial? 5. Uh-oh, what happened? I divided by 2, or 0.5, to the x. Is that a growth or decay? Like my teeth, it is decay. That was gross. That's gross, actually. Because my r is in between 1 and 0. It's a fraction. Every time I'm cutting it in half, it's getting smaller. Where this, if it's bigger than 1, it's getting bigger. It's growth. And if it is 1, then you're wasting your time with a function that doesn't do anything. We can make crazy functions that don't do anything, like me. All right. Look at us go. We're going to get this done in record time. Maybe. All right. Look at this beast. Oh, now we're going to look at shifting some, or we're going to just look at the functions. And we're going to bring in domain and range, because why not? So for any exponential, f of x plus 1 equals your b times f of x, okay? What this is saying, this is a goofy thing, but I'm going to tell you what it says. Like if I have 3 times 2 to the x, right? If this is my f of x, my f of x plus 1, what's my b? 2 would be 2 times my original function. Just because I'm just multiplying 1 more 2, right? That's just a definition, okay? They don't do a lot with it, but just be aware that that's a thing. Oh, here, I picked the same one. Look at that. It's like I scripted it, but I didn't. All right, if a is greater than 0, so my initial is bigger than 0, and b is greater than 1, then it's increasing, and the base b is called a growth factor. So if you're ever given a growth factor, that means how much it's going up by. That's also why, if we're doing a problem that's like a 20% increase, we don't put 0.2 in there, right? Because you put 0.2, it's not going to get bigger. You put 1.2, because it's going up by 20%. So now if I were to graph this beast, based on this, what's my y-intercept? They don't have it, but what's my y-intercept on this? It's always my initial value, right? So I have the 0.30. Can this ever get less than 0? Can I get a negative out by putting something to a power? No. So I think I talked about this in the video. What's my asymptote on these? 0. So I'm going to graph it kind of like that. If you don't hit the dot, you just draw the dot a little bit bigger. So what's, based on my graph, what's my limit as I go to the right on a growth? Infinity, right? It goes up. What's my limit as I go to the left? 0. Because remember, our end behavior approaches asymptotes. At least one side. You don't have to approach it from both. What's up? The y-intercept, it's your initial value. Whatever number's in front. Oh, yeah. Thanks, pal. Thanks, Miggy Smalls. I can say that one. Yeah, you heard it here first. He's in the room. All right. I'm going to write that 0 better because it's bothering me. All right. What's my domain? Is there anything I can't plug in? Anywhere where I have to lift up a pencil? Nope. It goes on forever to the right and to the left. So that's from negative infinity to infinity. Now for range, can't be negative, right? Can it be 0? No. Okay, there's nothing I can plug in that'll get me 0. It'll get me really close. So it's 0 to infinity, parentheses, parentheses. Wild. Nope, it cannot equal 0. It can't touch 0. Yep. Good question. Can't touch it. Can't, like MC Hammer. Can't touch this. Oh, that would be a fly Halloween costume. You guys missed it. I had a full costume. I was going to wear it today. I should have worn it anyways. Were you guys the ghosts? Yeah. I liked it. Yeah, who was it? Miss Lasky did me a solid and sent me pictures of the Halloween costume contest, and I appreciated it. Halloween's like one of my favorite days. What's this guy? I'm finding out present. No, do this. All right. All right. That's my initial. Now this time my rate is less than 1, isn't it? So if I keep cutting in half, is it going up or going down? Down. So it's a decay. Now here's what's interesting about decay. Will that ever be 0? So like right now, this is how they do carbon dating, right? You have carbon-14 in your body, right? Some radioactive molecules of carbon. It'll take chemistry or AP chemistry for sure. We'll talk about why that is. There's just isotopes that have 2 extra neutrons. They come off over time. Does it ever, after you die and you stop producing carbon, you stop making carbon-14, does it ever go 100% away? Nope, it will never 100% go away. That's even like if you eat caffeine, you actually never, you get really close to 100%, but any sort of drugs slowly decay over time. It's really interesting. They have a half-life. We'll talk about that later when we get to story problems. That's almost about, it's carbon-14 dating is so accurate to 200, don't quote me on this video, but it's only accurate about 250,000 to half because it gets to almost untraceable. So what they use now for dating is uranium dating, because uranium's half-life is like millions of years. So the rock next to the fossil, you can tell the age of something millions of years because uranium has a different half-life than carbon. It has a longer half-life. It takes longer to decay. If you'd like to learn more, stay in this class. We're actually going to do decay problems and show you how they do those calculations. All right. What's my initial value? 0.5. Now, what's this graph going to look like then? Yeah, you're just going to flip it, right? Oh, no. Can I do this? Ooh. That's not bad. That's not bad. I want it to... Yeah, that'd be what decay looks like. I stand by that. I'm proud of that one. That's pretty good. All right. Now this one, everything's just flipped, right? What's my limit as I go to the right? 0. I'm going to get closer and closer to 0. What's my limit as I come this way? Infinity. What's my domain? Still negative infinity to infinity. And did my range change either? Home on the range. Or domain on the range. Ooh, that's a song right there. Someone write it. Nope, always start with your smaller number. It's always in order from smallest to biggest number. And your asymptote is still y equals 0. So really the only thing that changes is the direction of it. Instead of going up, we're going down. This is my stocks. They're an exponential decay. Ooh, big tech. Okay. Where can I put this so it's readable? I guess I don't care about the internet people as much, because if you can't read it, sorry internet people, you'll have to buy the stuff. This is more for people with packets who can't hack it. I can say a lot of things. All right, so big tech. You guys know big tech. They have 25 locations. They're getting 10 new. The company growth is a B of x equals 25 plus 10x. So if that's their growth, is that going to be exponential or linear growth? That's linear, right? Because I have a slope and x, right? The x isn't being taken to power. Central computing has 25 locations, and they're going to increase by 40% each year, and their growth can be this. Now that's exponential, right? So we're going to compare the difference between what's a linear growth look like and what's a exponential growth look like. Okay? Makes sense? So let's plug it in. Year 0, where did I put, well, right away, what's year 0 going to be for big tech? What's year 0 going to be for central? All right, they're starting the same. Sounds good. After 1 year, this is going to be 25 plus 10 times 1, right? It's just 35. That's a quick jump. This one's going to be 25 times 1.4 to the 1, right? Which is going to be 35 as well. Right? Yeah. Do you guys need me to show work? I'm just going to give you the rest of the numbers if that's okay. So then this one just goes up by 10 each time, right? Oops, math is tough. This one goes up by, who knows? I got 49. I got 68.6. I got 96, approximately 96. Kind of a difference between growth and decay. What's up? Or not? For this one, we're going to leave it because I'm just showing difference. No. You can't. You know, you build half a building, yeah. Did you know? Never mind. All right, let's graph them now. Any questions on this? Oh. Dude, I should get dual whiteboards up here. Like get another screen over there. Have a screen inside a screen. I should just live in a screen. Have like a 360 screen. Get out of here. J-Mo knows he's bad when he's getting replaced by Donovan Peoples-Jones. All right, let's graph this beast. Oh man, this is a lot of dots. They both start at 25, right? I don't want to do this. 135, 2, 45. Oh wait, I can do this. So which one did I just graph? Big tech, right? Big tech. Do you think I can do this? Need a ruler? Or I can draw a straight line. Oopsie. That's not bad. That's not bad. Hey, listen. For a teacher, that's pretty good. All right, what color should I use for the other one? Blue? All right. All right, so that's big tech. Now this one we're going to do here and here, right? And then 249. And then what was 3? What was 4? And what was 5? What would it be? 134. That's too many. 8's that good. Now, when I graph this, since it's exponential, we have to have a little bit of curve in it, right? Oh, geez. Oh, geez. That's not bad. And that would be central computing, right? CC. Holy smokes. Oh, I just hit the mic. That's probably obnoxious. I'm obnoxious. All right. So let's do this. B of X is big tech, right? I'll stay consistent. We'll use this lovely maroon. So B of X, domain. What's my domain of B of X? What do we start at? Well, domain, so we're looking at X. We start at 0, right? Because it's a story problem, we don't come over to the left side. I'm going to bracket it because we have a point at 0, right? And then it goes from 0 to infinity. And its range is going to be what? Oop, I wrote a 5. 25 to infinity. Anyone disagree with that? So central computing, they're the same, right? My domain is going to be 0 to infinity, and my range is going to be, so they're the same thing. There's no difference between them, right? The linear and exponential, no difference. Good. Do they ever have the same value? Yeah. Which one? What's the max on this graph that my B of X will have? 75, right? What's my max that C of X will have? 134. The reason why we did this problem, pretty straightforward, right? If they asked you to compare and contrast, this comes up in AP Stats too. You got to state both of them, even if they're saying, okay, you're stating both. All right. So you should have all the tools and your ability to do 1 through 24 now. Sound good?